Melissa.
Hi, how are you?
I'm well. How are you doing?
Good. Just transitioning into the next phase of whatever snowstorm is coming. So
Yeah, I heard that out there you got a lot of snow. Is that true? Yesterday?
yesterday it was like 2 inches.
Oh, nice.
Nothing really stuck on the roads, which was nice, but the rest was on the yard. And so we were outside playing in the snow.
Nice. That's exciting.
Yeah.
Karen, are you there? Can you hear us? No, it's okay. Melissa, do you want to see if you can share your screen?
Yep.
Okay, hold on.
Okay. There we go.
Perfect. Great. And then I'm going to also see if I can do this because I believe I had the PowerPoint presentation for
Okay.
Karen
Yeah.
here.
Yeah.
Hold on 1 second. Okay, can you see that?
I can see that. Yeah.
Okay. All right. Dun, dun, dun,
Yep.
dun, dun.
Looks good.
Let's see here.
When we went into the exhibit, my 5-year-old was like, look at this. This is awesome. And she didn't run over. She knows, she did this fast little walk to get over to Interdependence. It was so cool. And I was like, yay, that's the one.
Yeah, no, it's a really cool
It's great. Yeah.
installation. I'm wondering, so there's a video here which shows it in its entirety.
Yeah.
Can you hear that?
I can. Mm-hmm.
Okay. The whale noises. Okay. Okay, good. Karen, are you there, Karen? Anywhere? No? Okay, maybe she just went off somewhere. So what we'll do is at 1 o'clock, I will It is now my pleasure to introduce our presenters for today. First, our docent presenter, Karen Liebman, has a BA in Arts Communication from Temple University. After 20 years consulting with companies communicate employee benefits information, she retired in order to concentrate on her art full time. Karen has been a docent at the Michener Museum since 2011, which has given her the opportunity to study the work of New Hope Impressionists, as well as the work of many contemporary artists in the area. Karen, welcome. Hello. Next, our professor from Del Val is Dr. Melissa Langston. Dr. Melissa Langston is an associate professor at Delaware Valley University, where she teaches analytical chemistry, general chemistry, and marine chemistry courses. Her research interests are in analytical chemistry education and the detection of environmental endocrine disruptors. Yes. She earned her bachelor's degree in chemistry from Kutztown University and her master's degree and PhD in chemistry at Lehigh University. She currently resides in Kutztown with her husband, 3 daughters, and 6 chickens. Welcome, Dr. Melissa Langston. Hello, Melissa.
Hi, thanks.
All right. That's enough for me. I would like at this point to turn it over to Melissa.
All right, thank you. Thank you everyone for being here. We're gonna jump over to a PowerPoint here. So let me pull that up for you. All right, so the focus of my research is on endocrine disruptors and specifically those found within the environment. So I'd like to just talk you through some of that today. as well as share a little bit about my major field of study, which happens to be analytical chemistry. So as the analytical chemist at Del Val, I get people showing up in my office frequently, and they'll hold something up and say, "What is this?" And I'm like, "Well, that's whatever you brought me," but they want to know what's in it. And so that's the job of the analytical chemist, is to say what's in that sample, to figure that out, as well as to discern how much of whatever that is that's in there. And so in analytical, we say that the field is both quantitative and qualitative. We can identify the presence of something, we can then apply a number to it. And so ultimately our goal is to gain more information about any sample that we might be presented with. So I'm always intrigued, in tying into the art world a bit, about the process that an artist looks at and goes through, and how they create their work. And so I thought I would share a little bit about the process that I need to go for to answer that question of what is it and how much is there. And so there's 7 steps that we say we look at in analytical chemistry. We first need to identify the question. What are we trying to solve here? So that's sometimes the "what is this" that person is holding up for me. The other thing that we need to then figure out is, what's the procedure or the method that we're going to follow? What are the tools that we will need to be able to answer our ultimate question there? We then need to look at our samples, preparing the sample, obtaining the sample, and so forth, before we can finally analyze our sample here in number 5, while then eventually getting to our results and drawing important conclusions. And through part of this talk today, I'm going to focus on that procedure and that method. There's a number of different techniques that we can use that you might recall from your maybe high school chemistry days. Sorry if that invokes any ill feelings there. But we also have some really fantastic instrumentation that we can get to use. And so there's no quiz on this today, but I just thought I'd roll through some of the pieces of equipment that we get to use here and give you an idea of how we can actually start looking at a given sample, and on what level we can get to as well. So starting here, we have an atomic absorption spectrophotometer. Again, no quizzes on the names of these. And this instrument's fantastic because it can take a liquid sample and actually tell us the metal atoms that are present within that sample. So we get onto the level of an atom. We then have here in the middle, this is a scanning electron microscope. These are really cool to play with, to be honest with you. And they tell us about the structure and the morphology of a sample, a solid sample that we can put into the instrument. And you can even see just on this, it's like a computer screen and a computer screen right here. You can actually see one of the images that's created. They're, again, fantastic to give you an idea of looking at any type of solid sample. We also have the ability to separate mixtures. And so we can separate mixtures, be it a liquid mixture, into its individual component by using a high performance liquid chromatograph. That would be this instrument here on the right. We'll actually look at some data that my researchers obtained using one of these. We also have the ability to separate gaseous samples as well. So this is a gas chromatograph down here on the bottom with a mass spectrometer. A mass spectrometer works in a way that it takes a molecule and breaks it apart, and then works to actually give us the fingerprint, if you will, of a molecule. So really great for identification. If you're a fan of CSI, you've probably heard them talk about the mass spec. That's what they were using there. And then lastly, it's not as fancy, but it's still a little workhorse in the lab, is that we can use a UV vis spectrophotometer, in which we're going to take light and look at how our sample interacts with light to give us some useful information. And so most of these pieces of instrumentation allow us to be qualitative for sure, and we even have the ability to be quantitative when we use them. And so I use these pieces of instrumentation when I go into my research, which focuses on environmental endocrine disruptors, a mouthful for sure, but it encaptures literally thousands of anthropogenic chemicals that ultimately affect endocrine system and the overall health of humans and wildlife alike. Anthropogenic, of course, meaning that they are derived from human activities. And so we see that these can be things that show up as a result of industrial processes. We see that they can also arise just from basic consumer products we all might have in our home. When we're looking at these types of chemicals, environmental endocrine disruptors, we realize that how one comes in contact with them becomes important. And so in most cases, we see that the exposure to an endocrine disruptor is actually over a long period of time in many cases, and it's also in extremely low doses. It's not common that there's a high dose that an individual comes into contact with, but it's going to happen low and slow is what we say. Low doses over a long period of time. And eventually we'll end up seeing that there's some significant changes that can occur even within the body. So the most common hormones that we think about in the endocrine system are estrogen, progesterone, and testosterone here. And so I included the chemical structures here because I think it's neat to see how similar they are in terms of these ring structures, as we call them, and also see how different they are just in terms, especially at the ends is where I always see the differences in terms of some of the groups that we find out here on the ends of these ring structures. I want you to, for a moment, you're going to take a snapshot of those, and we're going to refer to these 3 structures in a slide or so. But realize that the key thing here with endocrine disruption is where we're going to see the exchanges ultimately, these disruptions ultimately expressing themselves within the body. And so we see that they're linked to changes in metabolism. These things can typically show up in the form of something like type 2 diabetes, or more so thyroid problems that can develop. We see that reproductive issues, especially when we talk about estrogen and testosterone and progesterone, become issues as well in terms of infertility. And then we can also find that there's issues that occur in terms of the behavior and the growth and development. Now, these are things that can show up in utero, be it for a human or also in wildlife. And then we'll see that there can be challenges that the young face as well. And then finally, through the behavior of some of these endocrine disruptors, we can see that cancer can result. Now, an endocrine disruptor essentially has 2 choices as to how it's going to behave. It can behave in one way so that it actually diminishes the amount of the normal hormone within the body, so perhaps estrogen. And so in this way, the endocrine disruptor gets into the body, it makes the body think that it has enough endocrine, or enough estrogen, when in reality it doesn't. And so that's problematic because now the body's not producing enough estrogen. The second part to this is that the endocrine disruptor can choose to behave a different way, in which it makes the body think that it doesn't have enough of one of these hormones. And now the body creates an abundance of one of the hormones. So maybe it makes too much estrogen as opposed to before where it was making too little. So that's an interesting search in and of itself to look at the biochemistry and try to figure out how is one of these endocrine disruptors behaving and what pathway is it following. So for just a moment here, zero in on those structures, estrogen, progesterone, and testosterone. Try to, take that little snapshot here. And now I want to show you some of our endocrine disruptors. Do they look anything like estrogen, progesterone, testosterone? Not really. I mean, you can make some comparisons and say, yes, they have the rings, but they don't look identical or close to identical. They really do truly show some differences. Nonetheless, we see that, and this is of course just a small sampling, we see that each one of the molecules that's shown here is a known endocrine disruptor and has contributed in some way to the health conditions that we previously talked about. So just to give you a feel for some of them, we have bisphenol A, that's BPA. And so you'll probably find plastic materials that you have in your home, like my water bottle here is listed as BPA free, for example, implying that that bottle should not have BPA in it, where BPA has been used in the plastics industry as a stabilizer for a number of years. We also have polychlorobiphenyls. The polychlorinated biphenyls, or PCBs, are, as well as the phthalates, as well as the polyfluoroalkyls, all present themselves from industrial waste processes. And so most oftentimes we'll find these in waterways, and especially in the case of like a PCB, it does in fact work its way through the food chain, unfortunately. We also find pesticides in terms of our environmental endocrine disruptors. And here I chose atrazine, where atrazine is actually the original compound that was used in Roundup. While it's no longer used in Roundup that you may, spray on those weeds at home, unfortunately, atrazine does persist within the environment. And that is one of the key things about our endocrine disruptors, is that we see that they don't break down very quickly within the environment. We also have chlorpyrifos here. That is a pesticide that's still being used. This past semester, I worked with a small animal science professor where we analyzed bat brains for chlorpyrifos. She did the bat side of it, and I just had to analyze the brains. Didn't think I'd have one of those opportunities in my life, but there it was. And so we did, in fact, in the brains that we were presented, we found one bat contained chlorpyrifos within its brain tissue, but all of the bat brains we analyzed did have something else, which we're guessing is likely a metabolite of chlorpyrifos. And then the last structure here that I threw in kind of as a last minute addition is triclosan, where triclosan for a number of years was used in hand sanitizers. And since hand sanitizers are a hot item these days, as a consumer, I would recommend making sure there's no triclosan within the hand sanitizer that you might purchase at your pharmacy or grocery store. It is something that the FDA has limited, but nonetheless, it could still show up as a possibility. So now that we have a feel for some of those endocrine disruptors, and just to do that overlay of our estrogen, progesterone, and testosterone, we can see that there's some clear differences as well. As someone who's always kind of looking at new environmental endocrine disruptors, I do have to throw this in here for a lighthearted moment, where in my recent visit to the Michener Museum, I couldn't help but stumble upon this work here in the sculpture garden and think to myself, am I looking at another endocrine disruptor? So just having a little fun there. So why is it important to study these endocrine disruptors? A number of reasons. One is that not only are humans faced with the exposure to endocrine disruptors, but wildlife will be as well. We know that the exposure happens over a long period of time and at low doses. And so while we may not see on the front end some of these effects early on, when we couple environmental endocrine disruption to climate change, we realize that we're dealing with a catastrophic potentials here. Scientists overall agree that climate change is a serious threat to wildlife and humanity and the survival of species. When you couple that to the effects of endocrine disruption, the challenge becomes even more insurmountable. So it's important that we limit and avoid exposure to endocrine disruptors as much as possible. And so what I'd like to do now is shift into one of the research projects I had some students work on, where we'll look at how endocrine disruption happened there, and then try to pull into what direction that would mean and what that would mean in the wild, as these creatures would also be faced with climate change as well. So in one of my research projects, we used a compound called zeranol. And so you can see the chemical structure of zeranol. And again, if you've remembered progesterone, estrogen, and testosterone, you might want to say this one looks a little closer. And I'd give you that. It is derived from a mycotoxic fungus and sold commercially as Ralgro. Now, what's interesting with zeranol is that while it's produced in Europe, it's actually banned in the European Union from use. However, we still use it in the United States, primarily in the equine and cattle industries. It's used as a growth promoter. Now, studies have shown with using zeranol that cancer cells proliferate in existing cases of breast cancer. And so this is important because it's what it's showing us is that it actually forces the body to make more estrogen, which is likely why we see that cancer cell proliferation there. So what we chose to do in the lab was to look at realizing that a lot of our zeranol could in fact end up in a waterway. How is that affecting aquatic life? And so we chose to use a zebrafish. And so here's a zebrafish. You can buy these guys at the grocery, or not the grocery store, hopefully not the grocery store, but rather at a pet store. And you can keep them in your aquarium at home if you're interested. Where one of the reasons we chose to work with them is one, that they're easy to care for and easy to work with, but they also, interestingly enough, have a lot of genetic similarities to humans, and they're sensitive to changes within their environment. Also important to note that we could easily see any changes to the sex organs as needed and upon autopsy. So those are our zebrafish that we chose to work with. We took 2 groups of zebrafish and we put them in 2 tanks. So here's one of our tanks that we used in the lab. One tank was used as a control. The other tank, they were used as our test population, where they were exposed to a concentration of 0.003 parts per million of zeranol. That's not a lot, literally like a drop. We chose that concentration because there's actually no EPA limit on zeranol. And so we chose that because it's the same limit that atrazine is listed at for an EPA limit. And we realized that atrazine and the previous study looking at zeranol likely behave similarly within a body. So we then went on and analyzed our fish. We looked at their behavior, and then we eventually were able to look at their liver tissues as well. And so I'm going to switch my share here over to a brief little YouTube video, so you can see how our fish were doing here. Let me get this pulled up. What we had noticed early on is that the fish in both tanks behaved in a way that we would expect. They were schooling, they were just generally happy little fish in their aquariums. But what happened over time after we exposed the one group to zeranol is that their behavior changed. They showed that they were aggressive. We would see that they would chase one another. And so you might be able to see that in here. Maybe not the best. There's a fish there. I think it's also important to note that in this study, no fish died through the study and because of the study, but rather we did have to euthanize them later on to look at what was going on here. The other thing that we were able to observe.
Trust in Tractor Supply to have the lowest prices in town. Guaranteed. Find a lower price, we'll match it. Plus, take an additional 5% off. Learn more about our price match guarantee in stores or online at tractorsupply.com.
Thought I closed that window. Sorry, guys. Okay. We'll get back here. We did see on our zebrafish that they showed a yellowing of their body when they were exposed to zeranol. And we would also see that there were sometimes bulging midsections, which is what the next couple slides here show. So we have a yellowing. In some cases, it was like an extreme orange color that showed up on the body of the zebrafish. The females were primarily the ones that exhibited this color change. We also saw that our females had an abundance of eggs within them. In some cases, they would just kind of overflow when we started looking at the insides of the fish. Not only was there a large number of eggs in our zebrafish, but we also ended up seeing that they were discolored as well, which can, of course, imply that there would be problems in terms of that egg viability later on. The male zebrafish, on the other hand, they didn't fare very well here. We saw that their internal organs were gelatinous in material, and we sometimes struggled to find the presence of the testes in these male fish as well. And so in this case, it shows us that there's a strong likelihood that we can see that the zeranol is acting as an estrogen promoting chemical within the body, and we're producing too much estrogen, which explains the abundance of eggs, as well as then the decrease in or the lack thereof in some cases of the testes. Through sampling of the livers from our fish, we were in fact able to discern that zeranol was present in the liver. And so we know that the zeranol had been internalized within the fish, and we gained that information through our high performance liquid chromatograph, where this little arrow here is showing to our characteristic peak of our zeranol. And so what does this all mean for us? If we think about this in terms of what a zebrafish in the wild would face, in terms of climate change, it's going to be in warmer waters. Warmer waters means that there's less dissolved oxygen. So with less dissolved oxygen, that fish is likely going to leave its habitat, experiencing a loss of habitat, and move somewhere else. Now, where it goes, the question then becomes, is there food available for that zebrafish? When you look at that list of problems, and then you add the effects of zeranol into this, we see that there's some true problems that can arise. We see that there's altered behavior. They're aggressive with one another. That aggression, of course, means that they're no longer schooling, and so they're going to be more at risk to any predators that are in the area. We also realize that the aggressive behaviors are not certainly conducive to any type of reproduction and mating that would occur. We also realize those anatomy changes that we see are also not going to be useful in terms of reproduction as well. And so in that case, it threatens the survival of that particular species. We can extend this to our own lives and our own situations as well, where we realize that with climate change, we're looking at warmer temperatures. That's likely going to bring a change in our own habitats. We don't often think about where we live to be our habitat, or maybe we do now, right? In a pandemic, I guess it is more like a habitat. And so we realize that that change in what was maybe once an agricultural area could become an arid area where your food supply becomes limited, and there's obviously concerns about the access to clean air to sustain our lives as well. When we look at endocrine disruption, we realize there's problems with infertility and all the list of health issues that we've already talked about, thyroid disease and cancer and so forth. So what we face for climate change, not only does that play into what we see for wildlife, but it also affects our own lives and goes one step further where we can think about the already present health effects one might be facing. So again, adding more stress to a system. So in the last part of this talk here, I'd like to talk just a little bit about a method that was created using polyfluoroalkyls, or PFAs. Now, PFAs are an emerging class of environmental pollutants. They are something that we are seeing not break down easily within the environment, and it's likely because of their behaviors, where we see that they repel oils and grease and water. So they're great in terms of stain resistant. As a mother of 3 little kids, I'm like, this is fantastic. But it's a problem at the same time. So the primary places that you might find some PFAs, you can find them in carpeting. So if you're in the market for new carpeting and it comes with that stain resistant, it's likely a PFA that's being used there. Certain types of clothing, outdoor fabrics as well, are coated with polyfluoroalkyls. And then we'll also see that there's coatings that are being used on paper and cardboard. In fact, even the inside coating of a microwavable popcorn bag has some PFAs that are present within that. So maybe go stovetop from here on. You can make consumer changes at any time. And we also see that they can be used in firefighting foams as well. Now, the issue with our polyfluoroalkyls is that we see that they can cause a number of problems in terms of health. And so they can increase cholesterol levels. There's an increased risk of thyroid disease. We see fertility issues become present for women, including pregnancy problems in terms of serious conditions that can arise in pregnancy, such as preeclampsia. And then we can also see that there's connection to some low infant birth weights as well. And so one particular polyfluoroalkyl is called GenX as its trademark name, which is a lot easier than having to call it the hexafluoropropylene oxide dimer acid, which is what its real name happens to be. So instead, we're going to call it GenX from here on out. GenX is manufactured by Chemours, which is a subsidiary of DuPont in Fayetteville, North Carolina. What Chemours is doing is they're releasing PFA, in this case GenX, into the Cape Fear River is where that gets discharged. The issue that comes up here is that the Cape Fear River is also the drinking water supply source for the city of Wilmington in North Carolina. And so this has led to, of course, controversy as well as legal action, most of which, here's my movie pitch, can be found in the thriller Dark Waters, starring Mark Ruffalo. And so if you want to know more about this, check out this movie. I think we're getting a snowstorm, so it might be a great opportunity to Netflix this Dark Waters film. And so GenX, interestingly enough, isn't coming from an industrial source like Chemours, isn't the only way that we see PFAs entering a water system. They can enter the water system through wastewater treatment plants, which also discharge into local streams through, again, the firefighting foams, and even in some cases through soil and farmland runoff as well. But nonetheless, I think it's important to realize how many of these arrows are going down and where they're going down, right? These arrows are pointing to water systems, be it a river where it's affecting aquatic life, or even going one step further to saying that it's affecting drinking water supplies. And in some cases, we'll even see that it ends up in groundwater supplies as well. And so drinking water is the key thing here. Along those same lines, then becomes the question of, well, how do I know if my water is safe? And that's a fair question. And the work of some researchers that I'd like to share here, where GenX, they set out on a mission to detect some GenX. And so they primarily looked at river water from the Haw River in North Carolina and developed what they called a microelectrode. So this microelectrode, and here's an image of one. The very tip of this is in fact a piece of gold that has a width of 12.5 micrometers. That's the micro part there. So really, it's a fiber in all reality. And so this gold microelectrode, as we see here, wouldn't on its own really be interested in GenX. And so this group of researchers went one step further and worked on a way that they could actually modify that. And here's where I love the process. I love the procedure. I love the method that was developed here. Where what they did was they took a polymer, polymers are plastics basically, and they coated that microelectrode, this gold microelectrode, with their polymer. From there, they also added some GenX to that. And in doing that, they create, you can see the GenX is the star here, if you will, on this image. They went one step further here and made sure to insulate this polymer layer to make sure that it wouldn't be subject to oxidation. And in doing so, they then found that they were ready to remove the GenX. They removed it or extracted the GenX from their microelectrode. And this is the best part. They created little holes, if you will, or star-shaped holes from this image that are specific to GenX. And so that means no other molecule is going to fit into that space as well as GenX can. And so it now gives them the ability to go out to the river, literally to go to the river, put their electrode, their microelectrode in that water, and the GenX will interact with that while every other molecule should pass on by. And so I think it's a really cool process, a really cool application that creates a lot of possibility, because we can ask ourselves, well, what's next then? Because in reality, this is it's inexpensive, but it's really easy to use and really easy to look for water contamination. It's something that you could get into the hands of a consumer or a citizen scientist and essentially empower them to analyze their own water supplies to make sure that they're not exposing themselves to something that could have some harmful health effects for them. Along these same lines, when we think about what's next, we also should be thinking about what can I do? What's my part in this? So one of the easy things to do is to try as best you can to decrease the release and the prevalence of environmental endocrine disruptors. We know that they're going to be key to the survival, not only of our own species, but that of wildlife as well, as the impacts of climate change continually intensify. You know, I think we all can understand in 2020, like we have enough going on. You don't need one more thing. Endocrine disruptors are really the one more thing, I hate to say. The other thing that becomes important here is to be a smart consumer. And so while that might be easy for some of us based on our socioeconomic status, it also becomes important for us to be advocates as well, realizing that oftentimes our endocrine disruptors end up in products that on the market are cheaper and thus more accessible to another population. So it's important that we make a way to advocate for those individuals as well and to get the right products in the hands of others. And then finally, it's important that we understand what our individual role is in climate change and we work to minimize our carbon footprint as much as possible. And so I want to thank Del Val, of course, in the chemistry department, my undergraduate student researchers, particularly the work of Jared Cologne. He's now an alum of Del Val. He did a lot of that work. I, of course, want to thank the Michener in a more than challenging year. I really appreciate the commitment to rising tides that the museum has shown, and also their commitment to collaborate with Del Val. It's been a really great experience. And then I need to thank my own little friends who visited Rising Tides with me. These are my two youngest daughters. That's Harper, she's 5, and Nora, she's 3. They had a fun day at the museum. So with that, I'm going to turn it over to Karen and say thank you one last time.
Fantastic. Thank you, Dr. Langston. I really appreciate that. I love hearing about all of those. Reminder for everyone before we get to Karen, if you have questions, some of you have put them in the chat. Keep putting those questions in the chat. We'll get to them at the end. Now I'm going to turn it over to Karen, who I think has a special treat for all of us.
I certainly do.
Okay.
Thanks, Matt. Thank you so much, and good afternoon, everybody. Thank you so much for being here. So we're going to talk about one particular piece of art that's at the museum now at the exhibit called Rising Tides, and several contemporary artists are represented there. All women, 7 women who have been living and working in this area for many years. And the artist that I'm going to introduce is Margarita Hagen, who's here with us today, and her fabulous installation called Interdependence. And it all hooks in so beautifully with Dr. Langston's work. Margarita over the years has been very concerned with the environment and with climate change. And that concern, of course, is reflected in her work that you see here, the installation that's currently at the Michener. She is a ceramic sculptor. She's based in Philadelphia. And throughout her career, she's been inspired by nature and the oceans. And she has interpreted the beauty and the wonder of Earth's ecosystems and our role as stewards. She emphasizes our interconnectedness and our need to recognize how what we do has an impact on our environment. Margarita works in low fire clay, and as you'll see, she achieves these fabulous, complex structures with very intricate details developed through many stages and with amazing attention to detail. She received her MFA from PAFA, the Pennsylvania Academy of Fine Arts, and her BFA in ceramics from James Madison University. She's been involved with the community and she has been working in a project, a community arts project, very important, with people who are recovering from trauma and violence in conjunction with Drexel University. So I'm going to introduce you to Margarita so she can walk us through this fabulous installation called Interdependence. Margarita?
Thank you, Karen. Thank you so much for that introduction. Thank you, Matt. And Melissa, incredible presentation. This is a real honor to get to jump in here with Karen and share this piece. And this piece, Interdependence, is the title, really says it all. This is a time, everything is connected, and never more than now in the pandemic that we're living through is so important for all of us. As Melissa said, it's the connections within all life are so amazing, but we also are in this picture, and it seems like the humans are often forget that they can be damaged by our own hands, and the choices that we make, how important they are. This is my installation is 33 by 15 feet, Interdependence. It's a ceramic sculpture with a animated video projection that runs about 8 minutes, and it's looping, and there are 4 2-minute sequences. And we're looking at, just as it starts, this is a photo, given that the Rising Tides is honoring the 50th anniversary of Earth Day. So this photograph that the Apollo 17 astronauts took in '72 became the symbol for Earth Day, and it's the most recognized photograph on our planet. I laid out the work in the currents of the ocean, and they also extend out into what I call a marine Milky Way, because Earth is in a beautiful system, our universe, and we are one part of it. And I really wanted to present a big picture for us to see how we are all connected. And I'm going to show the video. And in the beginning, we're going to hear a hissing sound. I'm just going to pop through at different points on the video. But the first sound is the sound of space, a hissing sound you'd hear if you were an astronaut in space. And then, here we go. I'll just show this intro part. Rich, my collaborator, he's a cinematographer, took the photo and then brought it into life and animated it. So in a few seconds, the ocean currents and the clouds will start to move, and all the lighting is programmed into the your heartbeat here soon. Dr. Sylvia Earle calls the ocean the heart of our blue planet, and we must take care of our heart. We'll be hearing that heartbeat soon, and it'll be playing throughout the entire projection. I'm gonna speed us ahead, and you can see how things are moving. But we have the sound of a humpback whale singing, and it turns out they're a mother and calf, and they're going to be kind of giving a call and alert right there as we take a dive into the ocean. I play with scale, and these sculptures that are floating across the wall are microscopic, many of them, but also they go on up to like the blue whale, the eye of the blue whale. These organisms are our primary producers, these little jewels, and they can only be seen in a microscope. And there's so many of them in even one droplet of water, but they're the first life on the planet, and they have been supporting the entire planet for hundreds of millions of years. They know when they work together and form networks and colonies, as they're called, that they support all life on their planet. The diatoms and radiolarians are glass lace or silica structures that house plankton, and they're photosynthesizing plankton. So the ocean provides more than half of the oxygen for the entire planet. Skip on ahead to another point. We're gonna be seeing the green swirls will start to come into the screen. Now, what's really mind-blowing, in the springtime, these plankton, even though they're microscopic, they will bloom, and these have been filmed from space. So they go macro, and it's really quite extraordinary. Something that we need to learn from these microscopic organisms supporting an entire planet, how we work together, what's really possible and what we can achieve. The plankton blooms are just beautiful green swirls, and Rich animated that. Now the video moves across, and then it has a moment of quiet with just the light on it. And then at the very end, there's just a moment of just nothing but the artwork on the wall. Each piece on the wall tells a story, and there's much to discover within each piece, but all together they form what makes our planet possible, the blue planet. Let's see, there we go. The blue planet is because of our ocean. And like Melissa was saying, everything ends up in the ocean, because whether it's the groundwater, the streams, or the river, everything goes into every choice we make, and everything we do makes a huge effect. And it's time, we don't really have time for anything but a positive effect right now, and great transformation. This is the legend of the installation, and each piece is numbered, and the science name are listed there. So this is in the museum. It's also on my website. This is Rich and I at the show, my collaborator. So thank you very much. This museum has closed now, but we're really grateful that we can share in this way. And on my website, I have an e-sources page. It's sustainable, environmentally minded products and things. So it can be very overwhelming. And how do we really what can we do? But they're very simple little things that we can do that make such a huge difference. And that page is a great source to see some steps that we can take that are plastic free, little things we can do in our lives to make a big difference.
Great. Oh, wait, Karen, you're muted, Karen. Sorry. Here you go, Karen.
Oh, okay. Margarita and I were saying before how grateful we are that we're able to do this, since the museum is closed now. And if not for this technology, we wouldn't be able to do it. So, but if the museum does open, you know, it would be wonderful if people could go and actually see this installation in person.
Yeah.
So, thank you.
Great. Thank you, Karen. Thank you, Margarita. Now we have time, just a little bit of time for your questions. We already have a few here, so I'm going to get to these here. For Dr. Langston, Phoebe wants to know how is BPA banned in Europe, but not the US? Is that true? And why?
That's a really good question.
Money.
I think money is the answer there. Now, this is going back a couple years. I was at a conference talking to an individual who was working on what's the BPA substitute that the US has been using, which is BPS is what they're calling it. So I know that's a lot of fun there. And again, the work can take a little time because it's that low dose over longer periods of time. Some of the work that she was seeing was that the ramifications of BPS could potentially be worse than BPA, which is a little chilling when you think about that as well. But yeah, a glass bottle is definitely the way to go. If you can use one. I grabbed just what was in my kitchen this morning, which was the BPA free one.
Yeah. Fantastic. Thank you,
Mhm.
Melissa. Another question for you. Bruce wants to know, how has your work with endocrine disruptors affected your day-to-day choices, like the plastic bottle?
Yeah.
Are you like scouring, looking for everything? And do you have like the inside track on what we should be using or should not be using? How does it affect your everyday choices?
So when we moved into our home about 10 years ago, we have a well and we also have our own septic system. So that probably was the beginning of making some, what I think are smarter choices. I started using a lot more plant-based detergents and soaps and things like that. So I've been a fan of the seventh, I don't want to give a plug here, but like the 7th generation line, the method lines have all been great in that sense as well. There's always some neat products that are coming out. There's that toothpaste pod that you can use now, which I haven't looked into some of that, but that's on the list of things to add in the lab to get a student researcher on, because there's got to be a coating there that I'm interested in. Yeah, I can say that as someone who's also a mother, and knowing that children especially are exposed to a lot of plastics and a lot of plastic toys, and you don't think about kind of the dust that's associated with them, but as that kid starts moving those pieces around, there's going to be debris that falls off of them. But as that first time mom, I was really rigid, like, this is what we're doing. We're not doing this. We're not using these toys. And now by the third one, they've worn me down. So it's kind of a free for all. But I try as hard as I can to make better choices. I think it's important to look at organic products as well in terms of the food that you're eating. If you have the means to buy organic, that's important, because then you're avoiding a lot of those controlled pesticides that we should be fearful of. And we try on our property to do as much gardening, and then we do the canning of it as well to hopefully get us through a portion of the winter. So it really turns inward a little bit. That's why we have chickens, so that I don't have to purchase eggs, that we're getting them from our house and from our own chickens.
Great. Thank you.
I'd like to also add that was such a good question, but also you can not only just choose really good organic and consciously made products, but you can do that without the plastic bottles. So I don't have plastic bottles in my house for any of the basic things, laundry soap. And on my eSource pages, I list bites for the dental care. They're in a glass jar, and ET is Everything Touches Everything Else. They're out of Canada, but they make amazing products that are dissolvable. Well, they're all, healthy, good things. So you can go beyond even just what's in the bottle, but to get something that's not even in a plastic bottle, which is wonderful, because there are a lot of new options coming out now.
Great. Thank you, Margarita. One more question for you, Dr. Langston. Nicholas Shields wants to know, in your opinion, do you think these chemicals, Zernal, GenX, etc., can be used in safe amounts, or given how useful they are, or is the full ban the only way to go? Is it an amount of it, or is it?
That's a really good question, and a loaded one too. So as the chemist, I can say that when you put certain chemicals, there's a really neat study that just came out in Science, where they were looking at tires and how it was affecting coho salmon out in Washington and Alaska. And what they found is that there's a stabilizer. I'll use this as my example. There's a stabilizer in tires that's used. That stabilizer degrades, and as your tires spin and like little balls of rubber come off, they go into the waterways. that degradant product is causing the salmon to not be able to migrate and leading eventually in high concentrations to fish kills. So my answer here is that the chemist in me understands why that chemical is important to the tire. I understand that as the chemist, it's supporting the stability of the product that I'm making. It's eventually getting it to market, putting money in my pocket, right? I understand that also as the consumer, right? I just want to go somewhere. I want to get to where I need to be, and the tire is important for me to do that. The result of our activities, though, is the problem. And so, to be honest, I think there should be a ban on those chemicals, and that we have to make better choices, make smarter choices, and we need people to be working in science and engineering so that we can get around using those types of products ultimately. So it's a really tricky balance that we're trying to maneuver here. We're trying to sustain a lifestyle, right? We're trying to still have an economy that is functioning, while we're also then trying to do the right thing for the planet and for the wildlife that we don't realize we're affecting, but we truly are. So that's where, and the low, you know, in my area of study, that low dose, even if it is that low dose over long periods of time, we're still going to see problems within wildlife specifically.
Great. Thank you, Melissa. Last question here, and it's for Margarita. I want to know if you can jump in here. Bruce wants to know, will you incorporate the pandemic experience into future art projects?
Well, the message in my work is about our connection, and interdependence is like the rhythm in my practice. So it was incredibly critical before the pandemic, and now it's even more so important. I feel that it's already speaking to the pandemic now. So I don't see myself doing like looking at COVID virus and doing that unless I was collaborating with another artist or scientist. But I feel like my work was already addressing the issues that we're facing in the pandemic. And so I'm passionate to even do more of that. Thank you.
Great. Well, I want to take this moment to thank all of our presenters today, Dr. Langston, Karen, Margarita. Amazing information, and I love the way we can combine this information, important information, with the arts. I think this has been a fantastic series. We got to see how these things came together. I want to again thank all of our guests today who came and watched and supported this event. Thank you, everyone. And until we can see each other all again in person, I want everyone to stay safe, stay healthy, and stay arty, everyone. Okay? Enjoy your Tuesdays. We'll see you later.
Yeah.
Bye.
Thank you.
Bye.
Thank you.